On today's episode of This Week in Space, we're talking about the upcoming meteor shower, the biggest, the baddest, and best of them all, the Perseids. Stay with us.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 123, recorded on August 9th, 2024, the mighty Perseid meteor shower. Hello, everyone, and welcome to another This Week in Space, what I like to call the Mighty Perseids edition. I'm Rod Pyle, editor-in-chief of Ad Astra magazine, and I'm here with my good pal, Isaac Arthur, of the Science and Futurism with Isaac Arthur YouTube channel, which is very successful. How are you, Isaac?
Doing great. Glad to be back on for talk about meteor showers.
Thank you. And don't worry, you'll be on many more times. And today we have the pleasure of being joined by my old friend Steve Fentress, astronomer, physicist, and recently retired planetarium director of many decades. How are you, Steve?
That's true. And it's strange to be exchanging emails to set up a Zoom call. I haven't done that for 7 months. It's weird.
Well, don't get used to being off because we're going to have you back over and over. Before we forget, I'd like to remind you to please don't forget to do us a solid. Make sure to like, subscribe, and all the other groovy podcast things that we asked you to do because we're counting on you. And now, drum roll, a space joke from listener Jim, for whom I do not have a last name. Okay, I apologize in advance for this one. This is a boomer joke for sure. Why did Boeing's lawyers make them change the name to Starliner, Isaac?
I don't know. Why did Boeing change the name to Starliner?
Because they found out Edsel had already been taken. Okay. Anybody else got one?
What did the meteor say to Earth?
Hello, Earth?
Can I crash at your place?
I like that one better. Steve?
I can't. So there is a story that we used to hear that a college student was taking an astronomy class and the professor put a question on the test. Could you define what a meteor is? And he wrote, a meteor is a flash of light made by a falling meteorite, usually is seen at night, and I hope to God this answer's right. And it was, and the professor did give him full credit for it.
That's definitely a planetarium story.
It certainly is. It goes way back, and you know how far back it goes.
Yes, I do, because I was there. Well, I've heard that some people start chewing on their old gym socks when it's joke time on this show, but you, audience, can help. Save the cosmos from us and send us your best work, best, worst, or most indifferent space joke to twis@twit.tv. That's TWIS at twit.tv. And we'll be on our way. All right, we've got a lot to cover today, but I do want to do one headline because Starliner. Our email's been full of conversation about this, as are the various online forums that I monitor. Lots of experts or experts with finger quotes, depending on who it is you're talking to, on both sides of this discussion. This is polarized as the election. Bottom line, whether it's fair to criticize it or not, no matter how you slice it, Starliner does not work as advertised. Whether or not Boeing can and will fix it and or move forward with the program is an open question. Some of these sites I monitor, the folks listen to the press conferences and then everybody draws their different conclusions. The most recent NASA press conference was a real study in confusion. There was a lot of talk about the team's doing great. Our teams are wonderful. Teamwork. And the problem is that doesn't tell us members of the media anything, and that's who these things are supposed to be for. And a lot of these armchair quarterbacks rant and rave about the mainstream media doesn't get it, and we're not listening, and we're not paying attention, and we don't understand how hard it is to fly in space and all that. Actually, a lot of us do. We've been doing this for years. Some of us even went to school for it. And the problem is not so much how we interpret the press conference. Now, there are media outlets like USA Today that have a pretty light dive when it comes to this stuff. But for sites like Ars Technica and Spaceflight Today and others, they really do work hard at it. And the problem is there's been a real lack of clarity from NASA and Boeing in these press conferences. And the last one was probably, as much as I love NASA and their media department, one of the, I don't want to say worst, more challenging pressers that I've attended in a really long time, and they've been as fuzzy as a patch of mold about this whole thing. As I said, lots of remarks about the great team and validating data and so forth, but that only gets you so far. It's their job, NASA's and Boeing's, to be straight with and comprehensible by the media. And while I know it's a burst bubble to many people who have criticisms of how we're doing our job, there are a lot of smart people. I'm here joined by two of them, particularly Isaac, who's definitely a high tent pole in space media, and even engineers in this field. So, we got to continue to call it as we see it until we get something a little clearer from these guys. There was an article on The Bite, which is not exactly a high watermark of journalism, but they did a recent article on Starliner that cited some reputable sources and made one think. A, quote, unnamed but reputable source with NASA allegedly said it was 50-50 that Sonny and Butch would come home in a SpaceX Crew Dragon at this point. As we probably all know, NASA contracted SpaceX to study doing just that and other emergency return options on July 14th for about $250,000, which is cheap by space standards. And, we got Starliner sitting up there waiting to be used or not, costing almost double what the SpaceX Crew Dragon did in terms of the original contract. And Boeing rapidly approaching $2 billion in the hole on the program with no end of troubles in sight. So one wonders if Boeing will even continue this once they get their capsule back with or without a crew. It looks like SpaceX could be the sole provider for a while. And of course, the whole point of having two contractors is if one system packs up, you've got another to take people up and get them home. But at this point, that other would be the Soyuz. And that's not what everybody wants. But there we go. Any comments from the peanut gallery, gentlemen?
I would say, again, I've been trying to be as optimistic and favorable towards Boeing as possible on this one. I'm still glad there's folks besides just SpaceX in there because it's good to have competition. But I think the kindest thing we can say at this point in time has been that
well phrased.
That work needs done. So, a bit of a disappointment. And again, this is from an industry where accidentally crashing your probe can at times be considered a success. So the bar is not necessarily that high for getting success because we know how hard it is. It really is hard. And this doesn't mean they're bad engineers. They know how to build stuff. It's Boeing. But at the same time, this one has got to be labeled at best a failure.
Well, what's a bit of a head scratcher to me is, again, some of these the broad audience pundits say, well, SpaceX had longer to work out the problems of their capsule, although their problems in flight were never quite this impactful, as I recall. And there's some truth to that. However, Boeing, which absorbed McDonnell Douglas and absorbed Aerojet and Rocketdyne and absorbed North American Aviation, most remarkably, has a lot of institutional history. Now, how many of those people are there is another conversation, how many of them remain. But there is institutional knowledge. There's a lot of practice. They've been working on the space program since the late 50s. So it's not like they're a newcomer that's scratching their head over, gee, how do we make this work? So,
yeah, they've got the institutional knowledge there. They got they got the equipment, the supplies, the funding, the background. It's just this one has gone very poorly. As to why, that can autopsy afterwards. It doesn't look good, of course, and they're going to have to work hard, I think, to restore any confidence in Starliner at this point.
Steve, from your viewpoint, what's your perception of this whole thing?
A couple of things. I can remember being taught as a child, one of the big differences between the American space program and the Soviet space program is that the American program is done in the open. Whatever happens, everybody gets to see it. And the Soviet program is success stories after the mission is done, if that's how it comes out. And NASA has gone from NASA PR has gone from being kind of reluctantly granting information to people other than the big three networks to becoming a kind of an aggressive PR operation. I remember that from my days in the planetarium business. And I appreciated your comment last week or the week before about how every NASA launch telecast includes a slogan, a commercial right after launch.
Yeah.
Which is, and when I was working at the planetarium, I kept looking for clean versions of those videos that didn't have that. It reminded me of what I read somewhere about people yelling mashed potatoes right after Tiger Woods hits a drive, so their voice will be on the video.
Okay.
So yes, it's hard. It's technically difficult. It's organizationally difficult. But if we're getting just happy news from NASA PR, then that becomes suspicious.
Yeah, it's really frustrating, and I pine for being an old man. I pine for the days of the Apollo program when they just cited facts and told you how it was. And there was not, for instance, when the Apollo 13 accident occurred, which was a big deal, much worse than this because those guys were stuck in there. They didn't hold back much. They were pretty straight up, straight ahead, and announced things as they had them. So that's what I'm used to, but no use pining about that. All right, well, we're going to go to a quick break, and we'll be right back. And then it's all Steve all the time. Stay with us. Okay, Steve.
Hello.
Hi.
Nice to be here.
I now have proof that you actually listened to the podcast. I appreciate that. Give
Sure.
us a refresher on your background for people who may not have heard you before.
Well, 7 months ago, I retired after 28 years as the director of the planetarium in Rochester, New York. A great honor to be there. And the new guy who has taken over, Jim Bader, is very well qualified. And I'm sure he's doing a great job. But I made a point of saying I was going to disappear and stay out of the way. My formative years were back in Southern California, working at Griffith Observatory, where you did. And also a couple of summers at the Jet Propulsion Laboratory as a temporary audiovisual technician in the Von Karman Auditorium during the Viking Mars landing press conferences. So that really shaped my experience.
Yeah, I remember being very envious of you when you had gotten that job there. Didn't realize at the time you were sorting slides, but it sounded like heaven.
It was a lot of hurry up and wait and a certain amount of boring work sorting slides. Or the highlight was there was a trailer out at the far end of the hottest parking lot at JPL, a rented trailer where they had taken every educational publication that they didn't have any use for and thrown it in there for the last 10 years. And my job was to go out there and organize that trailer. So it's like 110 degrees outside the trailer. And I'm in there, but I was fascinated because I got to read all this stuff. The 16 millimeter film library, I was in charge of that, splicing the films and stuff. So I watched all the NASA movies. So there were exciting things like the press conferences and seeing the first picture of the footpad of Viking 1 on Mars. But also a lot of the tedious stuff.
I had to sneak into JPL or to Caltech Auditorium to see that first shot coming back from Viking, which in a way, I mean, I really wanted to be up at JPL, but mere civilians like myself weren't invited, nor actually were we invited to Caltech. I had to go in the back way, but it was fun being there with the press people. When the first picture comes back and it's a footpad and they're looking around like, why are we looking at a footpad? Where's the horizon? Where's that great shot of Mars? But that came in next. So
yeah, but that was the very first one, and there was nothing on the picture with legs or green eyes or anything like that, and no one knew at that point whether there would be.
So I just got to ask, in all the years you've been running the planetarium, what would you say the biggest crowd pleaser was? What show do they always like the most?
Oh, it's all over the place. And one of the things I think I'm proudest of the Strassenberg Planetarium is that we turned it into a very flexible, respected, well-liked community asset. So there's everything going on in there from Taylor Swift laser to astrophysics lectures to scout programs. A couple of things that really stick out in my mind were current events programs we did for the Voyager 2 Neptune encounter and for the Shoemaker-Levy 9 impact on Jupiter, back when satellite television and the internet were new, and we would run those, updating them daily and run them several evenings in a row, and the phone just wouldn't stop ringing. That was very satisfying. And then toward the end, I really enjoyed doing homeschool astronomy programs with middle school age kids. I think I have a soft spot for that age because, things are just starting to really click. And it's exciting to be in on that phase of somebody's life and show them all this neat stuff we have in astronomy and space.
Before I forget, I want to remind people that Steve has a book out, which is available on Amazon as well as other outlets, called Sky to Space, with a subtitle that's so long I can never remember it. But give us a quick blurb on that, if you would.
Yeah, Sky to Space, Astronomy Beyond the Basics with Comparisons, Ratios, and Proportions. So the idea here, this was really made to lead up to the April 8th eclipse, but it still has a lot of good stuff in it. And the theme is using like fourth grade math, how far in the universe can you get in understanding what's out there and what we can see? And the answer is pretty far. So a lot of the book is about predicting eclipses, but there's also things on the apparent size of the moon. We analyzed Chesley Bonestell's famous painting of Saturn as seen from Titan, and reverse engineer how he figured out how large to make Saturn in the sky, exoplanet systems, things like that. So it's still out there, and you have to update it for whatever your next eclipse will be, but the basic astronomy is still good.
So is your experience similar to mine, that you're not yet making a living just off that book title?
That would be similar, yes. Although there was a little bump last time I was on this show and mentioned it.
Hey!
So thanks, Rod.
Fantastic. It's a great book. It really is fun. And by the way, besides the planetarium work and astronomy and so forth, Steve is also a gifted artist and musician. And while the music didn't play a part in that book, certainly the artwork is impressive. I had not realized when you first told me about it that it was going to be not just filled with your drawings of things to explain everything, but even with your ability to still write with your hands, which is something that I lost a long time ago. So very impressive. 160
hand-drawn pages.
There you go. And done well. All right, Isaac, sorry, go ahead.
Well, we were talking about before you came on the show, when the eclipse came out, he had come right into my area to see it. We were just right down the road from my house there. We had a magnificent view of that in April. So the eclipse for a lot of us is one of those events that was once in a lifetime chance to go see something really amazing right from your own backyard. And I was thinking in a lot of ways that kind of leads to our topic for today of the meteor showers, because that is another one of those things you can just lay out in your backyard and see without telescopes, without anything, just with the naked eye.
And with less pressure about time and location with meteors as well.
Yeah. Oh my God, yeah. As a kid, I used to be able to sit out. We had a back patio of our house in Pasadena, California, which is not exactly rural, but I could still see stuff. These days, I still live in the same area, and I go outside, and there's just the sky is just this big orange wash with 3 or 4 stars poking through. So things have changed. It's getting harder and harder to find good dark skies.
Well, we had that anecdote going in for the eclipses because I have the freeway lighting coming off from both sides of my south and my west side. So when not very good for night viewing, but when the eclipse came, the lighting actually all turned on along the freeway. It was kind of neat. So, but yeah, it is not easy to find a good place to do a lot of nighttime watching anymore, even in rural areas.
All right. Well, we're going to talk a little bit more about that, and we actually are going to talk about the Perseids, and we'll be back right after the short break. Stand by. All right, Steve, tell us about the Perseid meteor shower and why it's going to be special this year.
Well, every year at this time, around August 12th, we have extra meteors appearing in the sky. And this particular event is called in the trade the Perseid meteor shower. And at its peak activity, you'll see maybe a meteor every minute or so if you have a dark location and can watch a lot of the sky. And you'll see it all. It's already all over the media and every website and every newspaper. It's a very happy story to be able to put up there something that you know is going to happen. This year's special because first, the moon will be out of the way. The moon sets around midnight, so you won't have moonlight washing out meteors. And second, we've got 2 planets, Jupiter and Mars, appearing very close together in a sky that's a part of the sky that's already spectacularly filled with bright stars, the Taurus Orion region. So starting about 3 o'clock in the morning, the eastern sky is going to be just beautiful even before you get to the meteors. So peak activity is expected late morning North American time on Monday. I would recommend this is more of a get up early thing than a stay up late thing. I would get up about 3 o'clock in the morning on Monday or 3 o'clock in the morning on Tuesday and watch till dawn if you can. Even if there are very few meteors, just for the 2 planets and all these bright stars, it's going to be a beautiful sky. So I've been calling this the second best sky event of 2024 after the eclipse, because you have such a nice combination of things going on.
Well, it is definitely a very cheerful event. Without, it's not a good news year for people to have something that's just happy to talk about, and nothing's quite so happy as having thousands of rocks hit the planet. But they're not really all that big, are they? I mean, we tend to think of, like, especially with Shoemaker Levy, that thing was huge, even like dinosaur huge. But how big is the typical meteor that we're going to be seeing on this upcoming weekend?
The analysis indicates that most of the particles that make a meteor shower, like the regular meteor showers that recur at various times of year, these are little particles from comets, and they range from microscopic up to a few millimeters in size. And they are crumbly comet material. They're not pieces of solid rock or metal, except for one shower, a different one that may be caused by pieces of an asteroid, but that's a whole other topic. So it's not actually rocks falling out of the sky. And if we have time for that, we can get into that, because everybody in the planetarium business knows that right after the Perseid meteor shower is a more than likely time to receive a phone call from somebody who has a strange rock and wants to know if it's a meteorite.
Which, of course, if you're in the planetarium business, as we remember from Griffith, particularly being up on top of the hill, which all of Los Angeles could see, they call you with just about every weird question they could think of. My favorite of which I've related before, was, hi, is this Griffith Observatory? Yes. Are you an astronomer? Yeah, sure. I found a frog on Hollywood Boulevard. What should I do with it? I thought, well, that is an intuitive leap for sure.
My interpretation of that is, at least they have enough respect for the institution to think you might know. At least you're a community resource, even if the question is not quite what you say you're in for. I would tell them I'm not a frog expert, but getting back to the meteorite question, I had the privilege of being the banquet speaker at a Planetarium Association convention a couple of years ago. And as a warm-up at the beginning of the talk, this was about 75 people in the room, many centuries of combined planetarium experience. And so I asked, by a show of hands, how many people have had a call at your planetarium from somebody who has a rock and wants to know if it's a meteorite? Every hand went up. Second question, in how many cases was there even a slight chance that this actually was a meteorite based on what you heard or saw? One hand went up. So it's actually, people find strange rocks, and we love curiosity, and we love the institution being respected as a resource, but your chance of finding a real meteorite is very small.
I'd say the last easily confirmable fall was that one that went hurtling through the ceiling of that people's house in Florida. Yeah. That one probably, you could safely say, okay, that's probably something from the sky, although it turned out to be a piece of the space station, didn't it?
Was it?
I think so. I remember as a young man trying to figure out why meteor showers were better after midnight, and it occurred to me, and I guess this is correct, that's because the Earth has turned and is now facing the direction that the rocks live in space. So they're hurtling in faster, and I suppose at a higher frequency. And the way I always envisioned these things was, in this case, the comet Swift-Tuttle crosses the orbit of the Earth along the ecliptic, the equivalent of the solar system's equator, and leave behind this kind of trail of gravel. And that's what we're seeing every year. Is that the correct assessment?
Yes, the Earth plows through this trail of stuff, and we can get into it if you want. When you have time, if you have time, the way the astronomers in the early 19th century figured this out. Just to get it started, there was a German astronomer way back in the early 1800s who was thinking about meteors, and he said, if meteors, if these are made by particles from space, and if they're arranged at random in space, and they're flying around at random in space, but if we see them coming in from some preferred direction, that could be a physical clue that the Earth actually moves in space, as Galileo and Copernicus said it did. And at that time, the only other physical proof that the Earth moves was the so-called aberration of starlight, which had been measured, very difficult measurement, about 100 years before. And that's where light arrives at your telescope at a slight angle because of the Earth's motion through space, so stars appear very slightly displaced at different times of year. It's a really hard measurement. But up till then, there was no other physical proof that the Earth actually moved. It was just an idea that made a lot of sense. And this guy came up with this idea, maybe it would be a good idea to watch meteors statistically and see if there's any trend beyond just total randomness. And that could be a clue about how the solar system is organized and how things are moving. And then it goes on from there, and I can get into more of that in the next few minutes. But I think it's great because it's this low-tech observation. It doesn't involve super-duper badass telescopes or high-resolution clocks. It involves a lot of people watching the sky and keeping records and then analyzing the records. And you can get this profound insight about where we are in the universe and where we're going. Long answer to a short question.
When I was running the observatory, the very small one we had at my university, on Friday evenings, we'd have some very interesting and strange questions come up. My favorite was, can you point this thing at the sun right now? And of course, it was about 10 o'clock at night, and the person said it with a completely straight face. But the other one that came up that was a little bit less bad than where
I like that question.
We got a lot of times was, how do I take photographs? And this was really early digital camera days. People started to get those little tiny early digital cameras. And it was very different to try to do long exposure times. For folks who are going to be watching this or might be setting a camera out at nighttime because they want to stay up for it, is there any kind of good method going around, photographing meteors? Any suggested advice for how do we actually keep this, in our memories?
The key is to be lucky, which means to take a whole lot of exposures. So there may be a way to do it with the software on your phone. Check around. I have an iPhone SE, so it's fairly simple. But I got great results from this 15 or 20-year-old Canon point-and-shoot S95. What I do is put it on a tripod, and then there's this software, hacker software you can download that enables you to get extra control of the camera. Set it with an intervalometer function. Intervalometer automatically takes pictures and over again until you tell it to stop. Set it to take 15-second exposures and just keep doing that until the memory card fills up or the battery dies or dawn comes and I stop it. And at the end, you'll have several hundred pictures and you go through them and some of them will have meteors. So that's what has worked for me. It's basically whatever your equipment, what you need to be watching a large part of the sky and have your shutter open as much of the time as possible because you never know when a meteor is going to come. So you take a lot of pictures and then look for the good ones.
Kind of going back to the idea of these giant banks of gravel in space, the comets leave behind. How long do those last for very long periods of time for us to go through, or does that have to get refreshed by the comet a lot? What's that actually look like?
Well, they get refreshed every time the comet goes near the sun. So we've come to understand that a comet is a dirty snowball, that it's frozen water and frozen carbon dioxide with a crust or mixed in or with a crust of kind of dark carbon-rich crumbly material. And these things spend most of their time way, 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 way far out in the solar system because they're on big elliptical orbits. And in a very elongated elliptical orbit, you spend most of your time far out, where it's very cold, very dark. We don't see them. But once in a while, they come in near the sun. The sun heats up these ices, turns them to gases. So they blast through the dark crust, shoot jets of material, including dust, out into the trail of the comet. And then the astronomer Giovanni Schiaparelli first figured this out in the 1800s. If you have a blob of particles that whips around close to the sun by the calculus of Newton's laws of gravity, that blob of particles will spread out into a long stream along the orbit. So every time that stream goes around the sun, it will get longer and longer. And if this happens, these episodes of pieces breaking off the comet, if those happen multiple times, you'll have multiple streams, and after a while, they will extend all the way around the orbit. So even though the comet may not be anywhere nearby, you may be cutting through one or more streams of material that it left behind.
So interesting you mentioned Schiaparelli, who, of course, is a little more nefariously known for having made copious observations of Mars and labeling, probably quite innocently, the lines he saw, which may or may not have been the capillaries in his retinas reflected back in his eyepiece, canali, which, of course, many, including Percival Lowell, translated into English as canals, implying artificial creation and so forth. So we love Schiaparelli for that. All right, we are going to take a quick break, and we'll be right back with more exciting news about the Perseids. Stand by. Steve, tell us, if you would, how we can best observe this. You mentioned dark skies, but of course those are becoming harder and harder to find. There is a website, I think it's called darksky.org, if I remember correct, where you can get more information on this. But if I'm in the middle of Pittsburgh or Los Angeles or New York City, I'm probably not going to see much, right?
Well, my suggestion is find a place where other lights are out of your field of view. And that may be hard to do too. LEDs have made light so cheap and unfortunately abundant. But if you can even just screen out the neighbor's porch light so that your eyes have a chance to adjust, your pupils have a chance to enlarge, and then relax in a lounge chair, watch whatever part of the sky looks darkest to you, dress warmer than you think necessary because meteor watching doesn't involve much physical activity. And if it's a clear sky, you're looking at something that's at a temperature of 3 degrees above absolute zero, so it's sucking the heat right out of your body. And just relax and give yourself watch as much of the sky as you can. As I said, if it's a good, strong meteor Perseid shower, it's an average roughly 1 or 2 meteors a minute. So not like a heavy rainstorm, but active enough to be interesting. Have your favorite warm beverage if you like. If you have binoculars, bring them because you can look at other stuff in between meteors and just enjoy it. And as I said, I would suggest if you have to choose, it's more of a get up early thing than a stay up late thing because the intensity of the Perseid shower increases as dawn approaches. So I would say 3 a.m. to dawn is prime time. And that's what I've been doing is setting the alarm for about 3 or 3:30 and go outside.
You know, when I was first getting into astronomy as a little kid, I got to go see Halley's Comet come through at one of our local arboretums. And I don't remember the comet at all, but I remember the advice I got from the guy about going into astronomy. I said, what's the big thing you need to know to do it? And he said, you need to dress warmly and bring hot chocolate and a thermos. And I was thinking, there are a lot of other showers besides, in August. So they might be very important to be wearing warmer clothing. Are there any other really good meteor showers besides the Perseids that are as reliable throughout this that we coming up for folks who missed this one?
Yeah, there are a number of relatively major meteor showers during the year. The other reliably good one is the Geminid meteor shower in December. So
definitely hot chocolate and warm clothing weather there.
Right. So it would be, I think the Perseids is the most popular one because it's a reliably fairly intense shower, and in Northern Hemisphere, the weather is nicer for being outside looking at the sky for 3 hours. But you have the Geminids in December and the Quadrantids in January that can both be pretty good. But rarely do people talk about sitting out in lounge chairs for those. Then there are several others during the year: Leonids in November, Lyrids in April, Eta Equorids in May, and the American Meteor Society, let me see if I can find my note here, has a list of all the meteor showers that they have identified during the year. Here we go. So they've identified, American Meteor Society, amsmeteors.org, lists 9 major meteor showers, including the Perseids and Leonids and Geminids and Quadrantids, 18 minor showers, 8 variable meteor showers, and 65 weak meteor showers, for a total of 100 over the course of the year. And those weak ones, that's like 1 meteor per hour as a member of the family.
That is a lot of space junk.
Yeah, well, there are a lot of comets and a lot of particles flying around. But for these weak ones, we're not encountering a whole lot. 1 meteor per hour per observer in ideal conditions. That's a lot less than 120 for the Perseids.
So just to cover all the bases, on any given night, if you're under a dark sky and the moon's not particularly bright or is down, you can see some meteors, which are called sporadics, as I recall. They're just out there.
Right.
But can you talk a little bit about, for these scheduled showers, if you will, the idea of a radiant and why that's handy?
Well, you pushed my button because I'm going to tell you the historical version because I find it fascinating. People were noticing, I thought the schedule of meteor showers, like the Perseids and the Leonids and everything, and the radiance had been known since ancient times, like Jupiter or the North Star. But no, wasn't until the late 1700s people started noticing, there are certain nights we have more meteors than usual. What's up with that? Then an astronomer wrote to this famous Belgian mathematician, Adolphe Quetelet, Quetelet, who's known as the father of statistics, and said, an interesting statistical problem would be how many meteors are there on an average night? So Quetelet actually created a network of observers in the early 1820s, set them out watching the sky, and came up with a number. An observer in a dark sky on average, nothing special going on, sees about 8 meteors per hour, which is still a rate that's accepted today. But then there were a couple of heavy meteor showers that people noticed and got people's attention. And there were astronomers in America working on this, not communicating very well with other astronomers in Europe who were working on the same thing. And a thing that really tipped it off was a very heavy meteor shower in the Leonid shower in November of 1833, where they were just raining out of the sky faster than anybody could count. So that really got astronomers thinking, all right, what the heck is going on with these meteor showers? Is there any pattern to them? So one theory was they're like the weather. You can't say why a meteor shower happens any more than you can say why a thunderstorm happened today. And in 1820, there was no way to know. The other theory was the cosmic theory, that they're caused by particles from space. So along comes our friend Giovanni Schiaparelli, one of the finest observers in Europe, and an influential.
Consequence of German-American physicist.
All right.
Somebody has Siri turned on.
Not
She's being
anymore.
as helpful as usual.
Not anymore. So anyway, Schiaparelli has the idea, okay, let's do a rigorous analysis of this. And he exchanges several papers with his colleague. Schiaparelli has an observatory in Milan, in a district called Brera, and he has one of the finest telescopes in the world and looks at Mars with that. He's communicating with his colleague, Father Angelo Secchi, S-E-C-C-H-I, who's down in Rome at the Rome University Observatory. And they decide, let's analyze what's really going on here. One thing you could do is figure out how fast these particles are actually going. Assume that the Earth is going around the sun. If you measure at the speed of these meteors, Schiaparelli found the speed of most meteors is about 140% of the speed of the Earth in its orbit. This is a magic number because in Newtonian gravitational physics, that's close to the square root of 2. And in Newtonian gravitational physics, the square root of 2 times circular velocity is escape velocity. So the meteors were traveling at a speed comparable to that of comets in big, long elliptical orbits or parabolic orbits. So that was the first clue that there was a connection with comets, was the speed. They had this... all the meteors had a similar speed when they entered the Earth's atmosphere. And then Schiaparelli, in this book of his, goes through very carefully with an argument from geometry about the radiant, which is what you asked about like 10 minutes ago. The fact that the meteors appear to radiate from one point in the sky. Well, the analogy that's often used is if you're looking along a railroad track, the parallel rails appear to converge to a point in the distance. So the fact that the meteors seem to emerge from a particular point in the sky, in this case from the constellation Perseus, that's a clue that they're traveling in parallel paths, and it also tells you something about the direction of the original cloud of particles. So he uses geometry to reason how the direction of the radiant would tell you about A, the motion of the Earth in its orbit, and B, the motion of the stream of comet particles. You could work this out with geometry. And then another cool thing that came along, his friend Secchi, who's mostly known for using a spectroscope to look at stars, meteors was not even a major thing with him. He said, if you have two observers like 50 kilometers apart and they could agree that they're watching the same meteor, they could note how high in the sky that meteor appears to them, put their data together, and use trigonometry, simple math to figure out how high above the ground these streaks of light are. That's a fun fact, but here's where Secchi was the genius. He says, and if you do a bunch of them and it turns out there's a maximum height, that could tell you how high the top of the Earth's atmosphere is.
Oh.
This is why I say these guys, I think of there's a temptation to think of these 19th century astronomers as a bunch of nasty old guys with beards. But these guys were really smart. And for Secchi, this is like an idea he shakes out of his sleeve. You know, you could find the top of the atmosphere by observing meteors. So they put it all together. Schiaparelli carefully reasons and identifies that the particles that make the Perseid shower share the same orbit as a comet that was discovered in 1862 that's now called 109P Swift-Tuttle. And then Schiaparelli says, okay, what could the connection between comets and meteors be? He looks back through the records. In 1618, there were detailed observations of a comet actually breaking into little pieces. Nobody knew what comets were made of, but this was the first observation that a comet could actually break into pieces. And Schiaparelli says, maybe that's what's happening, is comets go around the sun, sometimes pieces break off. They're in these orbits that reach this particular speed when they are near the Earth's orbit. And using calculus and Newton's laws, if a bunch of particles break off, after a few orbits, they're going to spread out into a stream that goes all the way around the orbit and has a certain speed and a certain direction that can be explained by the appearance of the radiant in the sky. And so from naked eye observations, not badass high tech, he puts together this profound insight into where the Earth is, how it's moving, how the solar system is put together. So I think it's a great story.
That is a great story. We're going to do one more quick break to pay the bakery, and we'll be right back. So stand by. We're back. So hold on to your seats. John, Jammer B, also known as, who's on the board today, has an image for us. So for those of you watching this instead of listening to us, we have a picture of a Perseid meteor from the International Space Station that was on the Astronomy Picture of the Day site, which is pretty cool. It's just a little streak. We see one of the solar panels. I think that's a solar panel, not a radiant panel, up on the upper right, the curvature of the Earth. We're past the terminator, so it's dark, and there's this cool little streak in the atmosphere. You know, this reminds you a little bit. I was very excited one year. Somebody was going to take us up in a private plane, and I thought, it's the 4th of July. I'll be able to see the fireworks from the sky. That'll be so cool. And they look like little sea anemones opening up, little tiny things. It wasn't very impressive. But this is rather cool because it's something that you wouldn't expect them to necessarily catch. I like it. Steve, before we started, that you had some stories about meteor lore, like in various cultures and so forth.
Well, there was, so I said that those astronomers back in the late 1700s, early 1800s that was when the first dawned on them that possibly meteor showers recur at predictable times of year. But it turns out there had been a tradition in particularly German Catholic regions that every August 10th, the sky brings us the tears of St. Lawrence. St. Lawrence was an early founder of the Christian church, and he was martyred in the year 258. And the particular way it was done, he was put on a gridiron and cooked over a fire.
Nice.
Pictures,
anyone?
The story about that is while the flames were licking over him, he said, "I'm done on this side. You can turn me over." And for that, St. Lawrence is now known as the patron saint of comedians for being able to make a wisecrack like that during such a bad moment. Mm-hmm. Anyway, the tradition was that these things coming out of the sky were either sparks from the fire or his fiery tears. And so there had been a folk understanding of this for centuries. Astronomers just didn't know about.
That's really amazing. I think one of the things people get confused about, I do myself sometimes, just like with stalactites and stalagmites. Can you just tell the audience, what is the difference between a meteor, a meteorite, and a meteoroid?
Yeah, the story is that if you have a little particle in space that hasn't hit the Earth yet, it's a meteoroid. And when it enters the Earth's atmosphere, it makes a flash of light by heating the air that it goes through. It's not hot meteor dust, it's the ionized air. And so that flash of light is the meteor. And if a solid piece makes it to the ground, then that solid piece is a meteorite. But people, here, reflecting over the year, I think during the eclipse, we gave people, at least in the planetarium business, so many do's and don'ts and rules. I'm not going to worry too much about those 3 words, but that's the technical difference.
And you said it's not a fireball, it's ionized gas. Do we get fireballs much with bigger ones?
Yes, if you have a bigger piece, fireball, let's see, the Meteor Society uses the term bolide, which is a fancy word for fireball, and that they apply that to any meteor that's brighter than any planet, like brighter than Venus. And so that would be from a bigger piece of stuff. And any of these regular annual meteor showers made of comet particles can occasionally have a fireball. You just never know when.
I remember once years ago, I was actually driving south during one of these showers. I think it was the Geminids. I was driving down from Northern California on the 5 in a relatively dark area. And I saw this massive fireball streak almost from horizon to horizon. It was amazing, bright green. And that got me curious as to what these various colors meant. So you can see a variety of colors, a fairly small set of them, but a variety of colors if it's a big enough display. What do those mean?
Well, there are known colors from different atoms, like orange for sodium and yellow for iron. I'm looking at my notes here. Blue for magnesium, violet for calcium, red and yellow from nitrogen and oxygen in the atmosphere. So you got different chemical elements in the incoming particle and in the atmosphere itself. And the colors, if it's really bright and the color is obvious, okay. If it's not so bright, the color can be pretty subtle and hard to judge. And remember that when you have something that's glowing incandescent, the color is telling you which chemical element is glowing the brightest, but not necessarily which one is most abundant. So, like if you see a blue meteor, that doesn't necessarily mean that this particle is made of magnesium. It just means that the magnesium atoms happen to be glowing the brightest. There's a lot of different kinds of atoms, some of them in very small percentages. But if they happen to glow the brightest, that's the color you'll see.
I remember we had the Aurora Borealis just maybe a couple months ago, and going out and looking at it, I couldn't tell if it was actually that or from the park up the road. But we took photographs of the camera because there's a lot of light pollution from that direction. We took photographs of the camera; it showed up so much better on the colors. You could really see the reds and the greens. And I was wondering because when we had the Aurora, you do get a lot of problems with the radio at that point in time. Do you have any problems like radio communications, cell phones, or anything like that during an intense meteor shower?
Problems. Not that I'm aware of. Observing meteors by radio used to be a thing, especially when television was analog, because the hot ionized air, ionized means that the atoms have had electrons ripped off. So you basically have an electrically charged gas, at least until the electrons in the atoms get back together. And so you have a cloud of this ionized gas, and that reflects radio waves like a mirror, particularly at certain frequencies, like the frequencies that used to be used for analog television. So people would set up receivers, and I guess you can still try it for AM radio stations. You want to set your radio to the frequency of a station that's like 900 miles away, but you can't hear it. And if a meteor goes over in the right place, it creates a temporary mirror up in the sky that will reflect that station's signal to you for a few seconds, and then it fades away. With the switch to digital, it's harder to do than it used to be. Professor David Meisel, who lives a few miles from me here and is a professor emeritus at SUNY Geneseo, was sort of a leader in organizing radio observations of meteors back in the 50s and 60s and 70s, but it's kind of faded. Some amateurs are doing it with more sophisticated digital equipment today and looking for digital signals, but it's not as easy as it used to be.
So a little bit of a steer to the right here. For years, we both worked in planetariums. You, of course, much longer than I, but I had a few years as a helper, not as a presenter. But it was pretty clear back in the 80s and 90s that these star theaters were beginning to go the way of the classical symphony orchestra, i.e. it was getting harder and harder to sell them as a show, as a presentation venue. And of course, different planetariums have tried different things. At Griffith, we ran Laserium for years, which looked like a lit up spirograph on the dome. I thought it was kind of silly, but it was quite popular. But planetarium directors and show producers have tried a variety of things. What do you see as the future, and what might be the way that this can hang on for something besides just young school kids?
Planetariums depend really, I mean, like many astronomical facilities, how well a planetarium does or what it does depends a lot on who the individual person is who is running it. And so if the individual person is just, renting canned shows from somebody, like, a movie or a laser show, and just running that over and over again, it's going to be a little dull. But the good news is there's a new generation of planetarium directors coming in their 30s and 40s. We've got now digital projection. So planetariums now have software. They can communicate easily with each other. Like if Planetarium A comes up with a good 3-dimensional model of the Crab Nebula, they can share it with planetariums B, C, and D. And there's some really smart people coming along. You can never do it on admission tickets alone, although I will say my planetarium, the Strassenberg, was doing very well on box office revenue when I left, and I understand it's doing even better on box office revenue since. And that's from opening up and being big enough. Yes, you can absorb running a Taylor Swift or a Pink Floyd or a Weekend or a Beyonce laser show or something like that, but developing the institution as a trusted and easily accessible community resource is what the new generation is into. And in the best places, it's looking really good because they're smart, they're tech savvy. Communication with professional astronomers is better than ever. We've got the internet. You can download anything you need quickly. So if you're talking about, it's like movie theaters. It's been a long time since movie theaters made any money by selling tickets to public exhibitions in the United States. So you're not going to do it on ticket sales alone, but the key to survival for a planetarium is local renown and respect. You need not only the tickets, but donors and sponsors. And if you are a valuable community resource, you can get that. And a lot of places are doing that. So another thing that helps is to spend money on improving the place. That certainly worked for us when we did our big renovation for the 50th anniversary. Attendance went up some, but revenue went up a lot because people were willing to pay for a better experience. And some extravagance is rewarding. Doesn't always have to make economic sense. People will support something that is really well liked and well respected. So I'm optimistic, actually.
So you're mentioning extravagance in shows like that, and I was thinking of so much science fiction where you've got these beautiful displays that are sometimes not always most scientifically realistic, but they help to let people really get entranced with the topic. And on my own show, we spend as much time in sci-fi as we do in science, and so I was wondering, do you have any good suggested reading for folks if they miss the showers? They want any good stories, any good films or movies that spend time on meteor showers and nighttime viewing?
Films or movies that spend time on meteor showers or nighttime viewing. I'd have to think about that. There are the biographies of astronomers that you can look at. Edward Emerson Barnard, Milton Humason, people who were not trained as professional astronomers. There's a book called Starlight Nights by Leslie Peltier, who was an amateur astronomer back in the 50s and 60s, who became a very well-respected observer of comets and double stars. And he writes in this with pencil drawings illustrating his childhood. Very beautiful tone about going out under the dark sky when he was a child on a farm in Ohio. I don't know of any movies that do a great job with meteor showers that I've seen. I will tell you, I'm going to steer a little bit off topic and tell you another popular culture connection, though. Remember, I mentioned Giovanni Schiaparelli figured out the connection between comets and meteors. His niece, Elsa Schiaparelli, was a noted fashion designer in the Art Deco era in the 30s and 40s. There's a profile of her in the New Yorker magazine. So she was just known as Schiaparelli, as Gowns by Schiaparelli. And she was the costume designer for a number of movies, including movies featuring Mae West and Zsa Zsa Gabor. So not directly connected to meteors, but if you want to look at the 1952 Moulin Rouge with Zsa Zsa Gabor, you're seeing gowns designed by Giovanni Schiaparelli's niece. How about that?
Did they have canali?
Among other things, they are talk about extravagance. She knew how to be extravagant, especially for a movie. Anyway.
Yeah, so I just wanted to ask one more thing for me. We've talked before about the Leonids, which can put on remarkable display every now and again. I think it's every 33 years, which I was fortunate enough to see when I was a kid in 1966. And it was, as a kid, it was terrifying, but it was also spectacular because the sky just lit up. When's the next time that might be expected?
We had a pretty good one in, was it 99 or 2000? I remember seeing intense meteors and a great aurora display on the same night. That was incredible. So it would be due again about 2034, something like that.
I guess we have to stay alive that long.
Yeah. So the Leonids can be one of the heavier showers of the year, but I'm looking at American Meteor Society is saying in 2024, don't expect more than 15 meteors per hour this time. But the Leonids, it's not going to be, I don't think, a big event for a while.
Isaac, you got any other questions?
I was going to say, if you want to learn more about Schiaparelli's work, you can always read up on John Carter on Mars for more of the canals. But if they want to learn more about meteors and sky observations, your book Sky and Space is still available, right?
Yeah, Sky to Space is still available, and it's really about I don't think I have meteors in there. It's more about things like, why does the moon appear the size that it does? How long does it take for the sun to set? How can you predict what you would see if you were standing on one exoplanet looking at another exoplanet in the same system? It's basically how you visualize things. A lot of it done by drawing what I call the skinny triangle, where the point of the triangle is your eye, and then the two sides of the triangle span whatever object you're looking at. If you can figure out how big that angle is, you can figure out all kinds of things about what you'd be seeing.
All right. Well, this has been great fun. I can't wait to have you back. And I want to thank everybody for joining us along with you guys for episode 123 of This Week in Space. We won't have that numeric lineup for a while. The Mighty Perseids. Please be sure to check out Isaac's YouTube channel, Science and Futurism with Isaac Arthur. Hope I said that right. For some of the most fascinating and brain-stimulating material you're likely to see anywhere. And you can, of course, find the National Space Society, of which Isaac is the president, and I do a lot of things, at nss.org. And Steve, remind us one more time, can we get signed copies of your book, and tell us about The Forgotten Bookshelf?
Right. So the book is available on Amazon. It's one of those print-on-demand things. So if you meet me somewhere, I'd be happy to sign it. But totally unrelated to Sky to Space, my new, since leaving the Planetarium project, is my podcast, The Forgotten Bookshelf. Readings so interesting they put you to sleep. Set your sleep timer for 30 minutes. So in this podcast, I read from things, mostly fairly old, on topics that they're fascinating. They just lead you farther and farther into irrelevance, like a book from the 1940s on how to load cargo on a cargo ship, a book from 1910 on how to operate a movie theater. Let's see, coming up in the new season, I'll have one on ice. If you don't have refrigeration, what's the best way to make a big block of ice outside? One on gravel. So this is a geologist about 1911 who argues why naturally occurring gravel is stronger than solid rock. Now, this should be of interest to you guys with your Mars settlements and your moon settlements. So that's coming up on the podcast, The Forgotten Bookshelf. Reading so interesting they put you to sleep. Set your sleep timer for 30 minutes, and you can get it at the usual podcast places.
I'll be sure to mention to my JPL pals when I see them that Mars Gravel is the thing. And of course, you can find me at pilebooks.com or at astromagazine.com. Do remember to drop us a line when you feel like it at twis@twit.tv. That's TWIS at twit.tv. We welcome your questions, comments, insults, and especially jokes. I'm counting on you. You're falling down on the job. New episodes of this podcast published every Friday on your favorite podcatcher, so be sure to subscribe, tell your friends, give us reviews. We'll take whatever you got. Don't forget, you can also get all the great programming with video streams and ad-free on Club Twit for only $7 a month. So if you go to the Twit website and feel like joining, we'd appreciate it. If you want to give more than $7 a month, we really appreciate it. But that $7 a month is helping everybody stay on the air in what are very challenging times for podcasts. Finally, you can also follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook, and at twit.tv on Instagram. Gentlemen, thank you. It's been a pleasure as always, and I'll see everybody next week. Take care.